Assalamualaikum warahmatullahi wabarakatuh. So in this video, our group will present on our project, which the title is Data Mining for Safety Helmet Detection. So these are the members of the group, and my name is Anis Najwa, and I'm going to introduce our project and also the problem statement. Farah will focus on the objective and results, while Fatin Najha will present on the data and data pre-processing, and lastly, Yana Amira will present on the selected data mining algorithm. So moving on to the introduction, uh, from what we have read, there are more than 50% of accidents on the construction sites that are caused by improper safety helmet use. This alarming statistic underscores the critical importance of the personal protective equipment (PPE) and the absolute necessities for the employees to consistently utilize the complete set of PPE when operating in the potentially hazardous environments like the construction sites. Um, the combination of data mining and object detection technology offers a promising approach to enhance the safety protocols and mitigate the risk on the construction sites. Besides, data mining also will enable the identification of trends and patterns, which will contribute to the continuous safety protocol improvement. Real-time data analysis also enables prompt hazard detection and compliance with the safety regulations. This combination will allow the construction sites manager to proactively safeguard the workers and will prevent accidents and also the injuries. Moving on to the problem statement, the current challenge in the construction site safety revolves around the issue of inadequate safety helmet usage, which is a significant factor contributing to accident and also injuries. Existing methods for safety helmet detection lack accuracy and real-time capabilities, posing a risk to workers' well-being. The problem at hand now is to develop an effective data mining solution that can accurately detect workers without safety helmets in real time, leveraging advanced algorithm to analyze the construction site data. So, by addressing this problem, the project aims to enhance the safety protocols, prevent accidents, and also ensure compliance with safety regulations on the construction sites, ultimately safeguarding the life and well-being of the workers. So, I'll pass to Farah for the objectives.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farah binti Kamal with metric number 1911974. So our project aims to achieve the following objective, and the first one is implementing a robust data mining algorithm that capable of accurately detecting safety helmets in real time. The second one is developing a system that can detect safety helmets with faster training time, high accuracy, and high inference speed.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fatina Zabatin Azamri, 1913984, and I will proceed our presentation today with data and pre-processing part. Alright, so for data set, we have managed to collect 2,343 of images, um, and we have split them into 80% for training and 20% for validation. So our data set includes people who are wearing safety helmets, like in the left one, and people who are wearing general helmet, like in the middle one, and the people who are holding a round shape and also wearing hijab, like in the right one. So all the data sets need to perform pre-process first before we feed into our model, into our algorithm, to train and validate it. Okay, so next, okay, for pre-processing part, we have used 4 techniques. First one is grayscale, the second one auto orient, and the next one modify classes, and lastly is resize. Okay, so for grayscale, it is used to train the model easier to process and analyze than color image. Okay, so here is an example of image where we perform the grayscale technique. So the left one, the image still has a color, right? Okay, so after we perform the process, the image turn into grayscale. So why we choose grayscale? Because it can focus on relevant features. For example, in safety helmet detection, system, the color of the helmet may not be as crucial as its shape. So when we convert the image into grayscale, system can focus more on the intensity variations and shape-related features that are more important for detecting the presence or the absence of the safety helmets. Therefore, it can also simplify the data. Okay, so when we convert into the grayscale, it can reduce the dimensionality of the image as we eliminate the color information. So this simplification can help reduce the complexity of the data and computational requirements during the training and inference stages of the safety helmet detection system. Alright, so what happens if we are not using this grayscale technique? So when we are not converting the image into the grayscale, the safety helmet detection system need to rely on color information for detecting safety helmets. So this means the system would need to analyze and differentiate the specific color characteristic of safety helmets, which could be challenging due to their variation in lighting conditions, color inconsistencies, and potential distractions from other objects in the scene. Okay, so the next one is auto-orient. So auto-orient can describe as-if rotation and standardized pixel ordering. So this is example of the auto-orient technique. So the left one, we can see that the image is slightly tilted, and after we perform the processing, the image turn into straight. So when we describe the as-if rotations, it can ensure that the image are in the correct orientation, so which is essential for accurate analysis and detection in computer vision tasks. So what happened if we are not using this auto orient, it can lead to potential misinterpretation. So image with incorrect orientation can lead to misinterpretation of the scene. For example, the safety helmet might appear as if it's not being worn correctly or is absent when it's actually present but incorrectly oriented in this image. So this misinterpretation can impact the overall reliability and effectiveness of the safety helmet detection system. Okay, so next, moving on to the third technique, which is the modified classes. So modified classes can standardize all classes from different datasets to save our time in pre-processing step. Okay, so here is an example of the modified classes. So the reason why we need this modified classes because since we are collected our dataset from different sources, so there are many classes, different name of classes that actually they are pointed into the same thing, which is safety helmet. So we need to standardize the name of it into no safety helmet and safety helmet only. Okay, so if we don't use this technique, it can lead to incorrect or inconsistent class labels. So for example, the dataset may use labels like hard hat instead of safety helmet, and the other dataset use safety helmet instead of hard hat. So we need to standardize the name of the classes here because it can lead to confusion and potentially inaccurate detection results. Alright, so the last one is resize. So resize can reduce image to smaller dimensions to decrease the training and inference speed. Okay, so here is an example when we perform resize technique. So the original picture, the dimension of it is 3088 and times 2316, and after we perform the resize technique, the dimension reduced into 640 and times 640. So resizing the image to a smaller size can reduce the computation requirement during training and inference. Smaller image require fewer computations and memory, resulting in faster training and inference times. So what happens if we don't reduce the dimension? So it can lead to lower training time and also inference speed. Okay, thank you. That's all from me. Thank you.
Okay, so now I'm going to be talking about the selected algorithm that is used in this project. This project is utilizing YOLO, which stands for You Only Loop One algorithm. Okay, why we use this I will talk about in the next slide, so I'll move on. Okay, so YOLO stands for You Only Look Once, as I mentioned before, and it is a popular real-time object detection algorithm. Currently, many people are using YOLO to perform object detection tasks because it has a very extraordinary features that enable it to produce a high accuracy with shorter processing times. There are many versions of YOLO, ranging from YOLO V1 to YOLO V8. The latest one is YOLO V8. However, we chose YOLO V5 to be implemented in this project because YOLO V5 has a significant advancement in real-time object detection, combining improved accuracy, flexibility in model scaling and scaling inference. On top of that, for YOLO V5, the average detection speed is 30 to 60 FPS. Besides that, YOLO V5 also has the capability to produce a high accuracy model, which is ranging from 0.6 to 0.8 MAP. MAP stands for mean average position. It is a type of metric that is used in object detection tasks. So when we wanted to evaluate, we will look at the MAP. The higher the MAP, the closer the MAP to 1, meaning that the model is performing better in identifying object and also classifying the object. So next, I'm going to be talking about the YOLO V5 key features. Okay, the first one is the model architecture. Okay, for the model architecture, the YOLO V5 utilizes a modified version of the efficient net backbone architecture, which provide better feature extraction capabilities. Okay, so for this one, YOLO V5 is also utilizing this one. It's also utilizing the efficient net backbone. However, YOLO V5 is using a modified version, means the better version of the efficient net backbone architecture to provide better feature extraction capabilities. So this is because when we do model training, we will need to extract the features from an image in order for the model to identify and locate the image in the instances. That is why feature extraction capabilities is very important. Next, the model architecture includes a combination of convolutional layers, which is the CNN, residual blocks, and other architectural enhancement to improve detection accuracy. So I'll move on to the second key features of YOLO V5, which is the scaling capability. Okay, YOLO V5 supports scaling the model size to trade off between speed and accuracy. The model can be scaled up or down to accommodate different hardware and performance requirement, meaning that we can adjust the model to fit our hardware requirement and also to fit our project. We don't have to use the fixed one for different projects. So we can use the different type of model for different projects. This is because YOLO V5 is flexible to do it. So next, I'm going to move on to the third key features, which is the enhanced performance. Okay, YOLO V5 achieve higher accuracy compared to previous YOLO version, especially on small object detection and crowded scenes. Okay, this is one of the main reasons why we choose YOLO V5. This is because our project is about safety helmet. So in order to detect safety helmet is very small. So we use YOLO V5 because it is performing better to detect small objects. So if we use other for example, if we use YOLO V1, V2, V3 or V4, the detection is not very good because they are not specialized in detecting small objects. So YOLO V5 is very good in doing this. That's why we are choosing this algorithm to be used in this project. YOLO V5 incorporates techniques such as focal loss, multi-label classification, and anchor-free bounding box prediction for improved performance. Okay, multi-labels here means that for our project, we will have two classes, which is safety helmet and also non-safety helmet. Okay, this is why this is because we want to see whether the model can differentiate when they see image which has safety helmet and non-safety helmet. So next we go to the fourth key features, which is the training enhancement. So for training enhancement, YOLO V5 introduced a novel training approach that is called CSP.NET 53, which is the acronym for Cross-Stage Partial .NET 53, which enhances feature extraction and promotes better convergence during training. Okay, moving on to the fifth key features, which is the efficient inference. Okay, YOLO V5 is designed for efficient inference and can achieve a real-time or near real-time performance on standard hardware. It takes advantage of hardware acceleration, optimized implementation, and advanced technique to ensure fast and object detection. Okay. Finally, the 6 key features of YOLO V5, which is the open source availability. Okay, so for this one, YOLO V5 is released as an open source project, allowing researchers and developers to access and contribute to its development. The codebase and pre-trained models are available on the official authority's GitHub repository. Next is the YOLO V5 architecture. As you can see the image, this image is actually the representation of the YOLO V5 architecture. Okay, the YOLO V5 architecture is a convolutional neural network CNN based object detection models. It consists of a series of convolutional layers along with other architectural components designed to perform object detection in real time. In this architecture, there is the architecture I mentioned before, such as efficient backbone and so on. So this is where it is being located. Okay. Next, I will talk about the step-by-step process or the working mechanism of YOLO V5 for detecting and also classifying an object. The first step, the image will be divided into a grid of cells, which means that YOLO V5 will divide the input image into a grid of cells. Each cell is responsible for predicting bounding boxes and the class probabilities for object within its boundaries. Meaning that, as you can see in the image, there is an image of a dog or bicycle. So this image will be divided into a grid of cells to enable the model to identify which one is the dog, which one is the bicycle, and so on. Okay. So for the second step, the YOLO V5 will calculate the confidence score that indicates the model confidence in the accuracy of the predicted bounding boxes. So the YOLO V5 will calculate the confidence score for each object that is detected in the image, and it will be displayed later. For the third step, which is to forecast the class probabilities, the YOLO V5 will predict the class probabilities for each bounding box, which indicates the likelihood of the object within the image. Meaning that it will detect the object and determine, is this the class, is this the correct one, like that. And lastly, for the fourth step, the YOLO V5, after it has detected, it will display again the image alongside with the bounding boxes as well as the associated confidence score. As you can see in the display, there is a bounding box generated around the object. You can see in the yellow box, the blue box, and also the pink box. Actually, there will be also a confidence score displayed, such as the 0.8 or 0.9 indicates that the model are able to accurately identify and classify the object with high accuracy. So this is why YOLO V5 mechanism is very important and helps us to see whether we need to improve our training or we can just use the model that we currently have.
After the dataset has undergone the pre-processing phase and YOLO V5 algorithm is employed for the detection and classification tasks, this is the result that we gain from the model training. For our project, we use 100 epochs to train the model. Based on the figure, it can be seen that the training accuracy increases as the number of epochs increases. This indicates that the model's performance in correctly predicting the levels of the training data improves with each epoch. After completing the training, the model achieved an impressive overall mean average precision, or known as MAP, value of 0.837. This indicates that the model performs exceptionally well in accurately detecting and classifying different types of safety helmets in the given dataset. Furthermore, the precision value of 0.886 showcases the model's ability to make correct predictions with a high level of accuracy. Approximately 88.6% of the model's classifications are accurate, highlighting its capability to minimize false positive predictions and provide precise results. Similarly, the recall value of 0.758 demonstrates the model's effectiveness in capturing approximately 75.8% of the relevant objects present in the dataset. This showcases the model's ability to minimize false negatives in ensuring a better detection and classification on safety helmets. Next, we move on to the confusion matrix. The confusion matrix was built using MAP50 and it reveals the model's performance in predicting the no safety helmet class has a value of 0.85. This value in the predicted row and true column for no safety helmet represents a true positive, indicating that the model correctly identified 85% of the instances of the no safety helmet class in the trained dataset. On the other hand, the predicted row and the true column for safety helmet class has a value of 0.77. It indicates that the model correctly identified 77% of the instances of safety helmet class in the trained dataset. However, it can be seen that the model misclassified 2% of the instances as safety helmet when it is in fact belong to the no safety helmet class. These discrepancies are common in the training process, and to achieve 100% accuracy in deep learning training has proven to be challenging. Overall, while the model demonstrates high accuracy, it still has room for improvement in accurately detecting and classifying the safety helmet objects. Next, I'm gonna play a video of our model testing for our project. I think that is all for our project. With that, thank you and Assalamualaikum.